Oh, hi. So, I'm firing this up, and we've got here, what I'll do is set this to a live chat in case we don't get people coming and being really harsh. And you got me making coffee, so I'm going to go and get the coffee that I made, as it is now 11:01, and it's probably ready. The mysterious and not there, Chris. Hello. Actually, this is even worse. Just a moment. Yep. That's a little better. So, yep, gotta always fool around with lighting and stuff because otherwise I look like a terrifying self-illuminated zombie or vampire or something like that. It can be very spooky. So we'll try to avoid being spooky. And hi, this is the Air Windows live chat for Monday, February 25th. And one thing I can do is hide OBS so I'm not looking at my face off to the side there. That being something. Also, my audio is screwed up, but I know that is just a matter of my playback. Nothing more. It doesn't really matter. Fooling with audio stuff. So yeah, I have just released MV. MV is my MIDI verb except for not, and in plugin format except for it's not anything like the MIDI verb, but it's using things from the MIDI verb, which is why it's called MV instead of being called MIDI verb. And David Pixley is getting me into trouble by getting me to say the name BitShift Gain. That's right, BitShift Gain. BitShift Gain is behind the entire concept of how MIDI verb works. And I have abandoned all attempts at YouTube compensation, which is fair enough, really, because that's basically nothing. That's the whole reason that our friend made Patreon. was that he was running his band Pomplamoose and making videos on YouTube, and he was spending $10,000 to do a video that would get millions of views and earn him $65.73, or now it would probably be $65.73. And yeah, the whole thing about MV is it's one of those testbed plugins where I'm trying a experiment to see how far I can push something. And in this case, it is doing a Bloom-style reverb with all passes in a row and using bit shifts instead of multiplications constantly. So everything it does inside itself, whether it's the all passes or whether it's the feedback or whether it is, this is a very good one to be asking questions about BitShift Gain, because this is the one where I say that name constantly and abandon all ideas of conning YouTube into thinking that I expect to get money from them. So, ask any questions you would like about BitShift Gain. If YouTube takes my money away, ain't that a BitShift Gain? I'm also observing random weirdness about I can't seem to make a video properly, or at least I can't seem to make a video to please some people, because this time I made a video in which I cut the microphone volume down to basically nothing after many times having people make me turn the microphone volume up way louder than the plug-in audio. This is the one where I turned the microphone volume down, and this is the one where people are like, oh yeah, I can't hear the effect at all, where I'm literally having the effect be the only thing you can hear. So that's really weird. So Bo, what is the story with low-level fidelity? Like, what do you mean by that? Dog breeders must have a terrible time on... Anyway. Bo's asking me about keeping low-level fidelity using BitShift Gain. And as near as I can tell, if you're using it in floating point, anything you do with it effectively keeps all the fidelity, period. Like, you're not actually going to get more Mantism no matter what you do or where you come from. So it's essentially lossless. Is that what you were wondering about? Because I'm puzzled as to how that would work. Oh, I see. So that's not actually a question about BitShift Gain. That's a question about analog. The deal with analog at super quiet levels is you do wind up getting noise predominating over it. And that's not just a factor of using tape, although tape is a very notable place where you get noise out of it. Noise also happens out of mixing desks. And I'll show you how. Burning through some more of this paper that I've got. So, as I've been thinking about mixers, in that I've got all of this sort of proto board stuff, and I'm thinking about ways that I can make a modular system where I can homebrew lots of things. I got a lot of parts. I got a lot of CMOS chips and things like that. And one of the things I need to be able to do is replace the roller mixer that I've got over here. I'd like to be able to build one, ideally one that performs better. And I've got some things like high performance op amps that would work for that. Hey, Bernard. I'm just not entirely sure where to go from there. So I'm going to draw you a picture of two different mixing topologies. One is passive and one is active. And what I'm doing is I'm drawing some scribbly resistor symbols. And this is one way that you can do a mixer, is you can take all of these little inputs, and each of them goes through a resistor and into the central place. And this is essentially what Air Windows Console models. It models the idea that each of the individual drivers has its limitations, and if you run them all together, the bus is going to have a input impedance. I'm not sure whether you'd say specifically the bus would have the input impedance, but an alternate way of doing it is like this. Now what I'm doing now is drawing some triangles. Triangles are the symbol for, they're not very good triangles, whatever. Triangles are the symbol for gain stages, and you can have minuses and pluses on them for inverters. We're going to assume that the actually, I may be getting this wrong. You can't even see what I'm doing, and it's already wrong. Oh, this is going to be a good day. Anyways. So we'll say this is a possibility. You could have it where, rather than just having a resistor, each of these are inverters, and each of them has a resistor on a feedback loop. Now, one thing that happens when you're running these op amps in this way is that making the op amp have the feedback loop like this, going into the negative input, means that it's forcing the input to be equal to ground. And what I really should do is take a minute and look up the document I have on that. I'll do that. This is a stupid day anyhow, so I'll roll with it and see what I can figure out of the information that I already have. I got a document on summing buses and summing amplifiers by Fred Forcell. It says a short discussion on summing buses and summing amplifiers. Let me bring back Firefox so that I can see what I'm doing. And indeed, I did get it totally wrong, so let's start over. What Bo is saying regarding the tape is low levels here. The main thing you want to worry about with nonlinearity in analog circuits is not so much whether noise is going to get in the way, but whether you have a Class A or a Class AB or Class B topology. And what that means is you got a waveform, and it has positive and negative things. I think you mentioned that that's one way things will happen. If you have a circuit part like a triode or a field effect transistor or a regular transistor that works by, let's say, It's this little thing. This is like what you could call a FET, and it controls what's called a junction, which is this area in here. You stick it between ground and a positive output. And you're taking, now I'm trying to figure out whether I'm drawing a transistor right. This could be challenging, bear with me. As my glasses fog up from the coffee. So the upshot of how this works, and I think I know how this has gone wrong. Let's draw a smaller circle here, and then pretend that we've got resistors everywhere. The scribbles are resistors. And then you take the output from this. And if this thing that controls the junction is, and now I'm confused about the difference between PNP and NPN transistors. I've spent a lot of years learning all of this stuff, and some days it's just not straight in my head. Well, it's also a triode. You see, a tube works the same way. The upshot of it is like this. You can have a simple circuit element where you put a voltage in somewhere, and whether the voltage touches the output in some way or is just floating around affecting it, you've got this area in here, and you can make it conduct electricity or not. So then hopefully answering this. And with one element like this, you've got a class A circuit. What that means is that nothing is ever around zero. Everything is always a positive waveform. We'll say that this is positive 1, ground counts as 0, so this is constantly hovering at positive 0.5 and vibrating around. And it also means that you can't go too far towards 0 or too far towards 1 without clipping the circuit element in here. But while it's in the middle of its range, what's going to happen is that it is going to be pretty linear because it's a single element being changed between conductive and non-conductive. The reason this matters is because you can have multiple elements, and the like the waveform that's split in the middle there, in which you got one of the things that handles the plus and another thing that handles a big minus. And you're running both of them at once. And the plus is making only the positives, and the minus is making only the negatives. This is what a class AB or class B circuit is. It's a class AB circuit if they overlap in the middle. And I'll draw them overlapping even though this is terrible drawing. You gotta live with my terrible drawings today. It's just not my good drawing day. A class AB circuit makes these voltages so that they cross over in the middle, and then you try to blur them a little bit. Because otherwise, if it was literally class B, you'd switch it directly back and forth between the one circuit and the other circuit. And lots of amplifier circuits work this way. Yeah, I don't blame you. I would drop out of a circuit class 2. I have a plugin to do this already. If you go and look up the plugin single-ended triode, you'll find that it has a control where you can make it do Class B type distortion and make it do Class AB type distortion. And one thing you can do with that is make it sound more like, say, a large Marshall amplifier or certain Hammond organ type sounds. Because I believe that some of those amplifier sounds aren't always biased perfectly, meaning that there is crossover distortion as you go across zero. And the thing about having something like that going on is if you have them not lined up very well, you get a weird artifact. And you can actually get stomp boxes and things to make this happen too. And I'm not sure if mine specifically does that, or it could be more like this. That's the opposite. That is an effect that is kind of like what you get out of U-Law encode, where the middle part just gets louder. Yeah, that's why I'm telling you. This is one of the services that I can provide in the live stream, is to tell you about the stuff that you might not have heard of. I don't remember specifically which one single-ended triodes Class A, B, and B do, but these are both crossover distortion. And this is the kind of stuff where analog can have really sharp nonlinearity as things get quieter. Because if you think about it, it kind of makes sense that if you have a discontinuity like that, I'm just drawing a random discontinuity rather than having it be anything specific. You can have a really big waveform, and the discontinuity is going to be the same size. Or you can have if you have a really tiny quiet waveform, the discontinuity gets relatively bigger. So one of the things you can end up getting with analog circuitry are distortions that are more prevalent for low-level sounds. So your question about low levels in analog being less linear the lower you go matters depending upon the circuit topology you're using. And if you're using a single-ended topology, it will tend to be pretty good going through the 0 point because there's no change. Nothing is happening other than the voltage gradually changing. And that's something that has in common with, like, digital math. Digital has an easy time of not throwing on that particular kind of distortion because it has all different kinds of distortions. But as you go with analog towards higher power circuits that are using Class AB or Class B push-pull topology, and that is a way of also getting linearity for the following reason. Do I have both sides of this page available? I have both sides of this page available. Check this out. 0. If you have a waveform and it's running out of steam and you're negative, like you've got this and it's single-ended, and the voltage that you have around the minus part is just running out of energy. What you get is a really strong second harmonic distortion, or indeed odd, even-numbered harmonics distortion, because the circuit is capable of making higher voltages, and AM radio did this as well. With AM radio, you could put positive voltages as high as you wanted, and it would just make the transmitter go louder. but you couldn't pull them back, so you would get very strong even harmonics. If you have the push-pull circuit, all of a sudden you're more capable of having symmetrical waveforms because the amplification stage you're using, namely a single FET, a field effect transistor, and a single-ended circuit. If you're using the single-ended circuit and it has any asymmetrical, well, you could also have positive distortions as well, depending upon the kind of circuit that you had. The point being, if you have a single part, like Nelson Pass's Zen-Amp designs and things like that, whether it's a tube or a transistor or a FET, which is kind of like both a little bit, if it is the one part, then depending upon how you set it up, it's not going to be symmetrical. And if it's not symmetrical, then it'll be generating even harmonics. And this is all the more true of things like output transformers, where you could have a, high-ender, low-power triode amplifier. And these are very popular in some circles around speaker powering. Where you got your single stage here. You've got a device that is powering the speaker. And because the speaker is a really weird load and difficult to manage, what you've got is a giant transformer. And the transformer has coils of wire. And what you're doing is you're running the energy from the electronic part that you use, whether it's a tube or something else, into the transformer where there's a iron core or a metal bar of some kind. And the coil that you've made is set up so that the electronic part that you're using drives it more effectively. And then on the bar, you're now converting it into sort of magnetic force. So the output coil can be totally different. In particular, you could have your speaker powered by, say, I think the way that it works is that the output of your speaker driving transformer is a much lower impedance. It has very few windings, but that is a more direct connection to ground. So the way these transformers work is if you can drive the magnetic flux properly, the ones with very few windings can actually do a lot. There is a kind of guitar pickup, actually, that can do that. The guitar pickup is called a lace Alumitone. I used to have them kicking around. I got rid of them. And it looks like this set of metal bars with some magnets in them. See, an Aluminotone looks kind of like that. And then what it's got is a transformer inside it, which is actually very small. But it's a special low impedance pickup because, hey Gamma, this metal framework made out of aluminum of the pickup is actually a coil. It's a humbucking coil. So the way that it's sort of set up is it's going through this transformer, and you've got some magnets there, and then those pieces of metal that look like they're the framework of the pickup, or they're serving a mechanical purpose of being what the pickup is made out of. Since there are loops of wire in a circuit that is part of a transformer. They are insanely low impedance inputs to the transformer, and the output of the transformer can power an amplifier. But if you just hooked up a speaker jack to the framework of the pickup itself, you'd get basically nothing because there's just not enough to it. It needs to go into the transformer to power it. So talking about blocking the DC is a very interesting point. We're going to go back to this electronic part driving a transformer thing. One way you can do this is to have the part, and we'll say that this is something that I could do in circuits as well. Like I could make Eurorack stuff based on this or any number of other things like that. One thing you can do is power the thing with a really high voltage, and this is what tubes do, through the transformer. So one thing that can happen with simple transformer designs is you're powering the signal with this high voltage source and putting it against the electronic part that you're using so that it develops power, and the reason it develops output is that it's able to modulate whether it's connecting its output thing to ground or not. Basically, if you have it like not hooked up, it won't do anything. But if you have it connected through to ground so that the principle of voltage here and it lets energy through, positive voltage here and it lets energy through, negative voltage here and it does not, or, positive voltage compared to zero and it does not, that will modulate the output based on what kind of voltage division you've got going on with the resistors and things. More coffee. I may actually have to go and make more coffee, which would be not good YouTube. But with a bit of luck, I'll be able to survive this thing. I may need to stop talking about circuits, though. I may need to stick to something that I'm better at, like drawing pictures. I would not be surprised, Spo, if the early Neve desks were made using transistors and transformers, because there's a lot of... The reason you stop doing stuff like this is for cost reasons. That's a big chunk of it. Because it'll just cost a lot more to do stuff this way. But if you are powering a transformer using your electronic part here, which could be a tube, it could be a transistor, whatever. If it's a tube, you might be powering it using a V plus of like 575 volts. That doesn't mean that 575 volts is going through the thing at all times and melting it down. What it means is that the tube is stopping it from flowing most of the time, and the changes in the... See, with the tube, I'm pretty sure that it's a gate. I'm thinking in terms of screen voltage for the tube, and I'm trying to remember the terminology. Because each of these things, whether they be transistors or FETs or tubes, have different terminology for each of the different parts, but there are similarities to all the parts. Like the little part that controls things with little tiny plus minus voltages might have a different name, but it has the same purpose. And with the transistor, it's kind of connected directly to the insides of the rest of the transistor, meaning that it will have a impedance like the connection to it will be connected through the rest of the transistor in various ways. So that, and quick answer, ICs are billions of these little things all connected together. ICs are lots of this stuff on a single plate contained into a box. Like this is an IC. And it's got the little pins, but inside it's nothing but a bunch of those little transistors. Or maybe it has some capacitors and things. There's other stuff that it can have. You probably can't focus on that. But all of these little connections just go through tiny, tiny wires to a whole arrangement of lots of these little transistors, and that's mostly what it is. Computer chips are even larger, except for when they're even smaller. They have smaller and smaller parts, and have progressively tinier and tinier transistors inside them. And they're all printed in an elaborate printed circuit diagram, which I think is usually pretty flat. But the bottom line is it's just lots of that stuff. The reason I was talking about the transformers is, oh God. You hear this? Can you hear that? I've tried that, they lie. Did you hear that? Sometimes I get several of those a day. I've looked them up at times. They are a complete scam. And I don't know why they single me out. And that one was unusually loud, which is why I thought maybe you could hear it when I pointed the microphone to it. I don't know why that one was that much more loud. It's almost worth getting rid of the phone, except for that is the phone that I can take calls for Air Windows on. So, anyways, single-ended transformers. If you have just one voltage source and it's going through the transformer, and the amount of current going through is any kind of substantial as it modulates its thing, you're going to wind up making the transformer more nonlinear. Like it will have a slight bias to it, meaning that it'll be trying to magnetize the transformer, and that will cause second harmonic distortion. So that's a mechanism where actual electric circuitry generates this other kind of distortion as part of how the circuit works. Now, here's another way that you can do a transformer. Namely, two-sided. And if you did one that was two-sided, and it has a center tap, and you can get transformers with center taps, so this is something I could do too, including at lower levels, and put power through the center tap. So that's a voltage. There's going to be a voltage on both of the ends because the voltage will go through both directions. It's just a wire. Then if you have two distinct amplifier circuits, and they both need to be powered by this voltage, and then the fluctuations in them modulate what's happening, you wind up with a thing that looks kind of like this, where you got more power because you got two of the devices, and both of them are symmetrical. One of them will be pushing and one of them will be pulling. They're in opposite sides, and they're both being controlled by a input thing. But in order to do this, you've got to have the input thing do opposite behavior. You can't just give them both the same thing. You've got to give them a opposite, one of them has got to be the opposite phase of the other. And since we're in just analog, here is the most refined way of doing that. Another transformer. If you got the output of another transformer, and that is just bolted onto both of these inputs, it will neatly make them be push-pull and in opposite phase. And if you've biased it so that both of these, turn on and off properly, you've now got a balanced push-pull. Technically, I think this counts as Class AB. It depends on how you bias it. Like if you bias it in such a way that this one only conducts, you could get something like this happening, where they're biased in such a way that if the level isn't high enough, neither of them work. And then as the level gets higher, you start getting the positive wave, and as the level gets negative, the negative wave happens because this flip side one starts to kick in. As you increase the bias to where they can turn on closer to 0, you'll have less of this behavior. And this is one way to make a power amplifier, or indeed a power stage on an amplifier. And it's also a way to give you balanced outputs for XLR inputs and outputs and these kinds of things. The only downside is the fact that, transformers are more expensive than chips. ICs are cheap. So let me wander away from this whole stuff for a moment and try to focus on what was actually being asked, because it got by me. Possibly also because I don't have a great answer for that, because it's very subjective. So Zephyr is asking, sometimes the song feels slower than expected in a tempo range. DC frequency can't affect that. I don't think there's any chance of that. What you're thinking of is probably psychoacoustic qualities, and the timing of the music might have something to do with it. I'm trying to remember where I heard this. This is in the many books that I've read about this kind of stuff. Some rock musician either a rock musician or an audiophile talking about the music of a rock musician. They were talking, I think it probably was the audiophile. This was out of something like Absolute Sound or whatever. They were describing the same behavior. And they said and maybe this is literally the answer to your question. It would be cool if it was. The fellow said, I have listened to probably like Rolling Stones' Beast of Burden or something. I have listened to this countless times, and now that I'm listening through this one marvelous amplifier, which has better quality than any amplifier I've ever had, so I can hear all the details, and it's amazing, and it's got better bass than it's ever had, and it feels as if the tempo has become way slower, that the tempo has become just monumental, is I think the word that the fellow used. So basically, what can happen is you can change your mix to have different equalization, different behavior, less in the way of artifacts getting in the way of hearing it, and depending upon how that modulates the mix, you can have a different perception of what the tempo is. Now the question becomes, given that you're working with a set tempo, do you want it to seem slower, or do you want it to seem faster, or what? If these have an effect on the perceived tempo, that is going to be just, what's your desired effect and what is your desired tempo, which is very relevant. I'm not sure if you're an EDM producer of some kind, electronic music producer. But that's very relevant in some ways because EDM genres are super dependent upon tempo. A lot of genres are almost defined by tempo more than anything else. The tempo and basic drum pattern is what it's about. Like, for instance, drum and bass has a very characteristic drum pattern, so characteristic that it can be incredibly monotonous and seem very repetitive. House has a drum pattern. There are different genres that are more devoted to 4 on the floor, that are more devoted to having some kind of snare backbeat in there. Two-step is a characteristic drum pattern, but the tempo also has a huge amount to do with what genre you're in, to the point where if you were making some kind of genre and said, "Oh, hi, here's my dubstep at 160 BPM," people would be like, "No, that's not dubstep." Or, "Here is my drum and bass at 109." And nope, that's not drum and bass, because drum and bass is a different tempo. It's a characteristic tempo. So it's worth being concerned what the seeming tempo is, but at the same time, what the real tempo is going to be a lot more significant as to what you do with the music than whether it seems faster or slower. So pretty much what I'm driving at, Zaffor, is this a problem or simply an observation? Like, is the apparent changing in tempo something that is making a problem for you, or just something that you're calling out? Because that becomes a creative input. Like, if you can start with the tempo that, say, I'm going to scroll back for a moment and see what you said. 120 to 128, you're in house. So if you're in 120 to 128, you're making house to electro house. Possibly not tech house, but possibly still. 120 is more along the lines of deep house. 120 is already too slow for some kind. Like, you can't be electro at 120 because it's not fast enough. But given that these tempos dictate what kinds of genre you can be in, having it seem like a different tempo is a way of giving a different effect out of the same basic functionality. And if you're focusing on 120 to 128 BPM, you're definitely in the house zone. And it's more a matter of how you want it to feel. 120 to 128 is dance music. Like, 120 is your more chilled, laid-back dance music. 124 is kind of a sweet spot. And it's not only house music that has discovered that. There is also the case of ZZ Top. And I'll tell you the story about ZZ Top. This is not my personal experience, but somebody else figured this out and apparently heard about what ZZ Top was doing. You may or may not be familiar with the ZZ Top album Eliminator. One key thing about Eliminator, and you'll never be told very much about it, like, I am moderate friends, not super tight, with Terry Manning, who produced the ZZ Top hit records, and he and Billy Gibbons, the sort of brain trust of the band, are very close-mouthed about the secrets that they did. But one of them got out, and that is their tempos on Eliminator. And somebody made a article about this that I've copied repeatedly and studied. And when I find things that turn up on the internet and they're amazing, I'll often copy them to my desktop and keep them around forever. This was like that. And the name of the article was 124 BPM. It's not just a good idea, it's the law. I'm pretty sure it was 124. I'll even go and take a little web search and find out. I'm searching for 124 BPM. It's not just a good idea, it's the law. And I'm not finding... Could it have been 128? I'm going to search for 128. And I'm not finding it there either. So maybe that is something that has been... I'll add ZZ Top to the search. It could have been, maybe it's 120. I was thinking 124. I thought 124 was the one. Nope. If I search for 120 BPM, it's not just a good idea. It's the law, ZZ Top. And you can do likewise. There's lots of results, and a whole bunch of them are talking about specifically Eliminator, which is exactly what the story that I'm telling. And there's lots of other articles about it. I'll tell you more things that aren't showing up in these articles, but in this case, it's 120, which is the tempo for the most sedate and chilled house music. That's a resting heartbeat. A resting heartbeat will hover around 60 beats per minute. And 120 doubles up on that neatly. So they designed it on purpose so that it emphasized this beat. You didn't have lots of faster songs. You didn't have necessarily slower songs, although I think there were some. You have ballads that were a slower BPM. But ZZ Top designed that album, like songs like Gimme All Your Lovin', around that specific tempo, knowing that that was the most popular tempo. And it worked very well. It's a big hit album, lots of hit songs off of it. And whether it's Gimme All Your Lovin', All Your Hugs and Kisses, I better not sing it too much or I'll get busted for copying it. Or Girls Go Crazy About the Sharp Dress, 120. That was on purpose. Another thing that happened that was quite interesting is Eliminator is like a proto-techno or proto-house music album, in that they're using, and this is similar to what Zafora is saying. You can do likewise. They're supposed to be a band, ZZ Top was. Granted, they're mostly Billy Gibbons' brainchild, and you got Terry Manning in there being very clever and thinking of things to do, and secret things to do, because he doesn't like revealing that stuff. Billy wouldn't like him. And you've got Dusty Hill and Frank Beard as bass and drums, but I'm thinking that it's Billy Gibbons is a little bit like, say, Jimi Hendrix, or indeed Eddie Van Halen in the studio, in that Billy had a tendency of wanting to retrack stuff. Like Jimi Hendrix did that, famously played bass parts on his albums sometimes, and sort of undermining Noel Redding. And Eddie Van Halen would sometimes undermine Michael Anthony and play bass parts on the Van Halen records. And I think there's every reason to believe that on Eliminator it was mostly Billy and Terry in the studio. And while they would sometimes have the other two playing stuff, they more or less went like, okay, we're going to do this. And you could have, like, I believe it's Frank Beard on the drums, the drummer playing the kit. But what ended up happening on Eliminator, I'm tempted to say more often than not, but I'm not sure that's true, is you would have somebody in there going, well, we're getting a lot of bleed from the snare drums rattling when you hit the bass drum. Can you do anything about that? And the guy's like, no, it would change the sound of the snare drum too much. And they go, okay, well, thanks. See you later. And then what they would do is go in and say, okay, take that snare drum out of the room. And they go, okay, well, now the cymbals are ringing when I hit the kick drum. I'm going stomp, stomp, stomp. And I hear a rattling to this tom-tom. Okay, take the tom-tom out of the room. All right, now the ride cymbal is going when I hit, okay, take the ride cymbal out of the room. And what they would end up doing is like, okay, here's our kick drum track. Here's the kick drum. That's the microphone end, just like it was. And we've taken all the other drum parts out of the room. And he would go in, and whether it be Billy Gibbons or whether it be Terry Manning, who is a very gifted musician in his own right, it's not necessarily MIDI. You think it's MIDI drums and synths, but it's not necessarily MIDI drums and synths. I'm telling you how they did it. I've hung around these people on the internet and their little forums and stuff enough to have been there when that kind of thing was talked about. And it's talked about only kind of tangentially, but still, people think it's just MIDI stuff. But first of all, Terry denies that it's all MIDI drums, and which is true. It's not. And then he is like for things like the synthesizer sound in Gimme All Your Lovin', which is one of the notable ones where he's like, that's a trade secret, I could tell you, but then I'd have to kill you. He says, we did this very interesting thing, and I'm not going to tell you what it is. And it's part of taking a click track and being able to put synthesizers and things to it. And there's like on early Genesis albums, and by early I mean MIDI era rather than the really early stuff, like the Building Blocks Genesis album, they would have stuff where they'd have a drum machine and it's going talk, 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 and it would be putting a voltage spike out of an output. So you had the opportunity to do just a trigger pulse. And that was not a MIDI trigger pulse. That was literally just a sequencer being like volts, 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 volts. And doing that sort of click. If you put it in an amplifier, it would just go tick, 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 without even much of a tick to it because it's nothing but a square wave. But they would put it into a synthesizer so that you'd hold down a chord, and the chord, and this could be an analog synthesizer. Back in the day, that's what they had for this. You'd plug that input in so that it was patched through into the volume output of the synthesizer. And then you'd play your chords, hold them down, and the output of the chords would be like, and it would be a machine tempo. The sequence output, kind of like, when I finish making this little toy, this will be a sequence output, and it will use the IC to go progressively down the outputs of the chip. And each of the outputs of the chip goes into this switch, so I could have them all set to like 4, and then this one set to 1, and then if I run a connection to the 1, then it'll be like 1, and then all the rest of them, then back to the first one again, and so on. Or several of them in a row like this, and that would make a trigger output. It would make a voltage that sort of beats out in this regular way, and that's how they would be doing stuff. So that could also be, I'm not sure what the time sequence was regarding, like I think old-fashioned transgate is exactly what we're talking about. Literally, that's what we're talking about. And that might have been Terry's secret, is that he was, I think the timing isn't maybe perfect, but it could have been just an early way of sequencing stuff using the primitive Transgate type stuff. And Terry basically being a classic rock multi-platinum engineer producer dude. I think Billy Gibbons was the producer. He might be keeping a secret about something that is not that secretive according to EDM folks. Like EDM and trance folks might just automatically know all of this stuff. And so Terry would be like, "Oh, I cannot tell you, it is a secret." And it's, "Oh yeah, the Transgate." You never know what other people know. You never know what other people consider obvious or not obvious. Here's something that you might not have known, also having to do with that Eliminator story. I just mentioned how, and this is something that was also happening with Genesis and other bands. I think Hall & Oates was doing this too, where if you are recording your drums, you got your drummer going on, right? He is in the studio. He's got his drum kit with his cymbals and tom-toms and stuff like that. And you go, you sound kind of garagey, dude. You hit the kick drum and everything goes, can we make this cleaner? Can we make this drier? We want just a really punchy percussive kind of thing. And he's like, well, I've already put 2 pillows into my kick drum. I can't make it be any damper. So you go, okay, take those tom-toms away. And you take the tom-toms away, and then things sound a lot more punchy. And you go, okay, so this one has a 4-on-the-floor beat, and I don't like that the snare is rattling. Take the snare away. And you end up with this stuff where it's like, okay, we're ready to go. Play your drums. And he's just stumping his foot. And going the entire length of the track, because we're still on the old tape machines and stuff. You've got to punch in, and you've got to make the thing go throughout the entire length of the track. But notice something about what we've done regarding take the toms away, take the cymbals away, take the snare away, is now you only have to focus on one thing. If you found that your foot was not regular enough, you could, like, lie down on the floor and punch the kick drum with your fist, or push it with your hand if your foot is too heavy and you're making too much of a thump. You need to make a very gentle thump. Okay, so you take your kick drum, you've taken all the other bits away, and you take your hand and you go for 3 minutes, and it goes thump, 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 consistently, way quieter than you get out of your foot, and as accurate as you can make it. You're perhaps listening to a click track in your headphones and you're just making it go. Then what you do is you go, okay, we left out the snare drum because we took it away because we didn't want it rattling on the kick drum part. And this is something that they did on the ZZ Top album that you think is MIDI drums. What you do is you go back and say, okay, now take the kick drum away. Now there's no drums in the room. Now let's go and get the snare drum mic that we used for when we had the kit mic'd up. And it's a different mic, it's going into a different input, EQ and stuff. Then you take only the snare drum into the room. And you can guess what happens next. You're going like thump, 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 thump. And you go whack, 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 really evenly. And if you're doing fills, like whack, 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 it's not going to feel the same as a drummer playing fills. It's going to feel more like MIDI because you're playing just the one part all by itself. And nothing else is in the room to resonate. So, like one of the tricks for making 80s drum parts, and the stuff that is very grooving but also very, very dry and punchy, is you take all of the extraneous drums away. Like take the toms off, take any cymbals you're not hitting off, and just have like a kick and a snare and a hat or something like that. Very simple. And play those. And it's actually a lot of fun, if you can stand it, to play a drum kit that is that simple, because it's kind of, you have to really like the groove aspect of it. There's a meditative quality about it where you can sit down and lay down a simple beat, and there's very little going on, and you can't play anything else because there isn't anything else there. And that is one of the secrets behind this older stuff that sounded kind of housey, sounded kind of early electronic, is you don't necessarily have to be using machines to power this stuff if you cut down the human performance requirements to where they can be handled. Like if you have only a snare drum and you know that you're only supposed to play a backbeat, you can sit there for 5 minutes, say, going. I think Bruce Swedian's thing is a device where he puts a foam dingus of some kind between the snare and the hi-hat. And it was used on Michael Jackson's Thriller and a bunch of other stuff as well. I don't remember the name either. But that is a separate thing. That is a way of getting more separation while playing the different drums at the same time. He's trying to isolate this stuff more. And remember, there is also another historical thing where, say, drum kit. Another thing that has happened in the past is that you had the Beatles recording the Sgt. Pepper's Lonely Hearts Club Band reprise, and they only had Studio A to record it in. Studio A of, I think this would have had to be Abbey Road, because that's where they were always working until they couldn't do that anymore and started going to Air Studios and such. But Studio A was the big room. And this was a fast-driving rock track. This was not a ballad. Yeah, exactly. You can do that. So what they did was you have like an amp here and an amp there, and they just walled them up with gobos. This is what they did for Sgt. Pepper's Lonely Hearts Club Band reprise. It's in Jeff Emmerich's book, which I have and recommend, that when they needed to do that track, they could only work in Studio One, and Studio One was huge, and it needed to not be a ballady like so they made this tiny room out of walling the guys up with gobos into this little tiny space. And part of what happens from that is the reverberation is just the natural bleed into the microphones from the larger room outside. Like that's what the room sounded like. If not for the gobos, it'd be overwhelming. And the gobos make close reflections. Lots of little close reflections. It's like they're in a shoebox. It's like they're in a closet or something, like a little bitty tiny drum booth. And because it's gobos, and you could do the same thing with like doors. I have a thing that I've built in my drum room right now, where I had doors handy. And so I've literally built a thing that looks kind of like this. And I bolted the doors to the other doors. They were older wood doors that were in my house. I liked having it be more open and just walk from place to place rather than constantly opening and closing doors all the time. So I had some of these kicking around, and I decided to use them as gobos. So my drums now live here. Sort of tucked into this conglomeration of doors, and the already fairly small room that I'm in behaves like an even tinier room, except for that it also behaves a little bit like Abbey Road Studio One, because the doors are enough to completely break up the audio in it. I have hopes of doing things with these drums in future, like making more recordings of them. I've finally gotten it to where the recordings that I make are pretty darn good, and it's been a struggle over the years of being able to get closer to that. I have a couple of little tweaks to make, like I have a substitution for the kick drum microphone that I use. I essentially built one for the purpose of having it be bassier, but there's a dedicated kick drum microphone that I could use, which I think would be better. And then it becomes a matter of just, setting it up with the limited set. It's very possibly just kick, snare, and hi-hat so that I can put beats in that way. And the custom kick drum thing in there. And I've got a miking that other people don't use and that I like. It might not be the best idea in the world, but I like it, so I'm continuing to do it. Rather than miking from overhead or something like that, I have two mics on opposite sides of the kit pointing inwards. And they're supposed to center around the kick drum or center around the snare drum, but I got to move them until they're the right place. The sounds are in the right places. And if I can do that, then I have a stereo mic pickup with good centeredness and a good sort of presentation. And then I also have the kick drum mic, and I'm trying to work out a way where the kick drum mic is just wired through a passive resistance mixer into the other two mics, which are then like the one good preamp I have is an API, and I've got channels available for that. I could technically do a dedicated kick drum mic for it, but I'd like to just run it into the other two mics as a reinforcement and set them up in such a way that it's reinforcing the lows just enough that I'm getting a decent mix out of it. It's doing it super the hard way. It's doing it very much the hard way, but I have a hunch that it would be a thing that works good. And various other weird tricks that I'm doing to make things happen. Like I'm getting a lot of highs out of things even though I'm using the Air Windows modified 57s. Because I like that as far as things like snare sounds are concerned. I think you can get very good sounds out of those. But you don't get the highs properly. So basically what I need to do is take the output of the API and pad it down with a gain cut that lets high frequencies through. So I've made that as well. That is a piece of hardware that I built for myself and that nobody else has, but I could make them or at least show people how to make them. So let me go back to live chat for a bit. I'm lucky live chat this time because live chat isn't being assaulted by anybody. If they do, I'll just change it over to top chat. But let me see what we've got. Mute Tourette's has a observation. Yeah, Bo has also mentioned something that the if I had a spare NS10 woofer, I could make a subkick. The thing about making a subkick is that would reinforce things great as far as the lows were concerned, but then I wouldn't get the beater click off of the kick drum, and I'd like to have that. So, because the beater click off of the kick drum is a strike on a large mylar diaphragm, which then sort of crackles and vibrates in a characteristic way. It's not just a tick. It's a whole sound having to do with hitting a drum hard and having the plastic vibrate in a particular way or break up in a particular way. I mean, I'm even specifically doing that because both my kick drum and my snare drum are set up like this. Zero is high tension, X is low tension. So what'll happen is it'll almost like, it'll be a high tension drum everywhere else, but this place where I've let off all the tension, it'll like rumple up. I've done piezo element on the surface of the drum. That actually works amazingly well, but it is also just a click, so it doesn't get this. If you have the drum where part of it's rather than being evenly tensioned, it's just all. With the snare, I tend to have it all super tight. With the kick drum, not so much. I tend to run them really loose. But with a part of it rumpling up, means that any vibration will tend to like crackle and vibrate to a halt in a particularly noisy way. And you mic that, and it gives you a lot of extra information that shows people where the beat is, rather than a simple click that will just go away very quickly. Yeah, and I did put a piezo element on the drum shell. If you put a piezo element on the kick drum shell, what happens is you mostly don't hear anything until you really lay into it. And when you really lay into it, you get a super clearly defined and very high output click. It is a really good, very specific click sound. And you just run that into your mixer and use it. The challenge that you got with that is that you'd have to limit or compress it to have it be anything like usable, because it's almost inaudible most of the time. What's happening is, as you hit the drum, if you hit it really, 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 really hard, you're compressing everything inwards, and it's that the piezo element picks up. And then by the time it bounces back, the vibrations aren't going through to the shell nearly as much. So you're getting only the sharpest bit of the attack, and it sounds kind of like a beater click, but it also sounds like an electronic click. Like you had some kind of circuit going along with it. It's neat. It's cool sounding. I didn't find it to be all that totally useful. Now, I just skipped over. I mentioned Muteritz himself and then skipped over him. You're asking about slew rate being too much for DACs. I need you to bounce back to me and tell me what that means. Because I don't remember talking about slew rate being too much for DACs. There are other people who do. There are other people who say you shouldn't have high-resolution audio because all it does is generate this intermodulation stuff and make amplifiers sound bad. And I don't know if I agree with that. I'm not wedded to the super high-resolution stuff. Depends upon the kind of music you're making, and depends upon the kinds of sounds you need. But I don't think it automatically just makes broken sound. However, the thing about slew rate and DACs specifically is kind of like this. It's all the coffee. With slew rate and DACs, what's going on is like this. Suppose you've got a waveform. And this exists in the world somehow. You've made a noise that made this happen, maybe by whacking books together or breaking glass or I don't know what. But you've made something that has this incredibly sharp information. And your DAC is going to want to put out samples at these positions. Now, that might... Yeah, good observation, Bernie, because what I'm going to be trying to do when I get the drum thing really working better is using my two sides of the drums mics and then the internal mic that'll work like a subkick, but I want to use an Audix D6 for it because that will generate a really artificial tone that will reinforce exactly the bits that I need. So it will give more click. It's all about the click. And then it'll also give loads of just super low stuff, and I'll balance it in there, and that should probably be what I need. Anyways, in the max slew rate, and I'm not sure there's a specific, like 12,000 or 14,000 sounds like kilohertz in audio, and that depends upon what the sampling rate is. But what I'm telling you is literally that. It's just that it automatically happens as you handle things. And this is also what causes a particular kind of digital problem that I don't generally produce. If you are trying to take samples of these spots, and I'm going to draw some of these dots and some of this stuff. I'll draw dots on the waveform. Yeah, you can. I wouldn't be expressing that in terms of 12,000 or 14,000 unless I was measuring with some completely different waveform, because the samples are measured between mostly 1 and -1. So unless I'd scaled them up to the size of 16 bits. Anyway, the concept remains regardless. If you were making sample points, what you'd end up is getting some dots, and they'd be leaving some of this stuff out. Now, what DACs do is record at a much finer rate using a thing called delta sigma at lower resolution, so they can follow these wiggles all the way down to here and back up again. So the DAC is able to follow that stuff, but then as it's generating the higher resolution digital audio at the lower sampling rate that it needs, it starts sort of dividing it up to where the output is going to end up being kind of the same, but you'll notice that some of the parts of the waveform are just not there anymore because the sampling rate won't support it. So when you capture stuff directly off of a DAC, you never have the problem of the maximum slew rate being too much and causing problems with the playback, because it's going to take that away for you. Then if you boost it, like you boost your high frequencies using a plugin, this is probably what I was talking about. If I mentioned this with regard to recording albums off vinyl, probably what I was doing was saying there are frequencies on vinyl too high to be captured on CD, which is true, but nobody wants to believe it. People are like, CD is perfect. What are you talking about? There's way more treble on CD than there is on vinyl. But it's true that you can put stuff on vinyl that can't be recorded in CD. When you sample it, basically, it's going to convert it already. What happens when you exaggerate the samples that make up this recorded file that's going to play back fine? Yeah. Or say you put it back to where you have successfully mimicked what the vinyl recording had. I'll tie it back into the vinyl because you've been mentioning the vinyl recording. And you made it so that, say, your waveform does have the weird spike on it that the original sound had. And you're trying to reproduce it that way. What's going to happen in the playback is that the reconstruction filter will take the samples that you've got and try to make them come out the way it expects. and you're going to have problems. Because when you make the samples seem to mimic this, the one that was filtered and has lost some of the audio, your samples are even not that far down, and the end result, once you've reconstructed it, is still not quite the same as what you had, but it's more than what you think. Like if you have samples like this, the playback will never actually just go from the one sample to the next sample and so on, filling them in. Instead, it's going to try to make a waveform that would have been sampled there, and it's going to do a crazy thing. And assume that because of math, what you really recorded to make those samples be there was this. Because if you recorded this and then broke it down to the individual samples, that's what you'd get. The samples are not the audio, is the bottom line there. And that is also like the business with recording albums off vinyl and looking at maximum slew rates is simply having to do with the preposition that there's sound on vinyl that cannot be represented on CD. You can do it just fine at like 96K or 192K, but you can't do it on just literally 44.1K CD. And that is demonstrably true because there have been quad formats that used amplitude modulation of carrier tones. And it's a really bad quad format. It was a terrible idea, didn't really work. But the quad format used like 48K carrier tones and half-speed mastering and stuff in order to be able to make quadraphonic sound that you could play off of a vinyl record. And the fact that it worked at all is demonstrable fact that you can do that. And you're not wrong, Tourette's. The thing about this is, see, this answers your question right here. If you have high frequency sounds and you also have lower frequency sounds or whatever, and then some of your high frequency sounds go out to the point where they've got to cover stuff like this, then that's as loud as you can get. Like if your 1 and -1 for the digital audio samples are here and here, and your sound has a high frequency part that generates something like this really pathological thing. It's called Gibb effect. You can't get away with louder than this on the mastering without clipping this. That's what I was saying, and it's not wrong. That is assuming that you're not going to just roll off the highs or slew limit. I've got a plugin called Acceleration that would fix this immediately, and then you'd be able to go as loud as you wanted. This is about the accurate representation of sounds that might have existed on vinyl. So let me scroll back to see your literal question there, because I feel like I've answered it and you feel like you haven't. Can you talk us through the issue with slew rate being too much for DACs? I think I just have. Do you need to be told like what to do in the DAW to fix the problem? Yes, I can tell you that too. Yep, exactly. Gibb effect. That's exactly what you need to be thinking about. So in order to fix that problem, what you need to do is roll off the high frequencies, or slew clip, or slew limit, or use acceleration, which acts like a slew limit, in order to make those high frequency things not do this crazy stuff, the Gibb effect stuff. Because you can't just have samples anywhere between -1 and +1 that has the capacity of generating stuff that will overshoot. And I will do a lovely little graph for you to conclusively finish the question. Let's say these are samples. They're -1 and +1. So in theory, this is as loud as you can get, right? This could be a square wave at any frequency that you'd like. Since the give effect means it can only slew so far and so fast, it's got to reconstruct stuff and it's got to reconstruct stuff within the bandwidth. You can never make a square wave with just sharp corners going from this to this immediately. What it will do is take this sequence of samples and do a crazy ugly thing with it where you've got huge big overshoots that sound nasty when you put them in playback. And that is why you can't just take samples and do whatever you want with them. And as an end result, if you did take a square wave and sample it, you'd start seeing some funny things going on. And you'd have samples that look kind of like this for what would be a real square wave. And then the reconstructed waveform would act kind of like that. Maybe with a little bit of wiggle on the extremes. And it's just not going to be as steep as this. There's no way that you can make anything that steep. You can't change you can't get a slew rate this fast. It's got to be kind of slower, which might mean putting some of the samples in the middle of the transition, when technically with the square wave that you've recorded, there were no things within the middle of the transition. The square wave, say you're using a signal generator, and it's good up to radio frequencies. So your sound literally was like that. But you've got to sample it. You've got to get it into the computer. So since there is no radio frequency transition between plus and minus in digital audio, rather than make a big mess like this, it's going to sample it and it's going to put some samples in between where they don't belong, just to make it transition from the one to the other. So how's that for answered? I think that's a pretty conclusive answer. So yeah, let me bounce back here a little bit and look at some of the other talking questions and stuff. Honestly, Colonel Porridge, for a plugin guy, I like doing as many things outside the box as possible because that's kind of how I grew up and was raised. Oh, well, volume does affect what slew rates you can get away with, and I'll tell you why. This is a maximum slew issue. With this, you can only slew so far before you are moving too fast and generating these overshoots. On the other hand, if you had something like this stored within the range of the digital audio, like say we take our radio frequency square wave and we make it much quieter. Rather than get something like this where you literally can't restore it, or something like this where it's putting interpolation in, we've got samples in the middle just to make it go from the one to the other. With the little tiny square wave, we've got enough room to have small modulations. And you get something samples kind of like this. Since it's not so loud, there's room to put the samples in places where they will reconstruct it accurately. And then when we do the final output, we get something that's squarer, and the angles are not as sharp, but the farther away we put these sort of defining points, like if we have enough room to put these extraneous points way over here, we can sharpen the edges of that apparent square wave. In so doing, we're telling the reconstruction filter, oh, no. Not just straight from one point to another at an angle. Make it steeper. No, steeper. Even steeper than that. And what you end up doing is having the very sharp stuff that's, way off to the sides there. And then the immediately preceding sample is totally on the other extreme. Like, they wind up wildly jumping around as far as the sample positioning goes in order to tell the reconstruction filter, like, no, steeper than that. And you end up having to do stuff like with our series of sample positions. I've drawn those without enough space, so let's step them in. With our series of sample positions, we've got a parent angle like that. You see, this is exactly why I was saying that thing about the limits of slew. Suppose we want literally vertical. And I can't do it. But if we wanted to make it try to do that, what we're going to do is make the sample positions go increasingly crazy. So the ones right to the opposite side of it, it's like we're stretching the angle to be steeper and steeper by making them go farther and farther away, and they can't go any farther than the full range of -1 to +1 on the output of the reconstruction filter. Like inside the computer, you can do as much of this as you want. Then the one directly adjacent to it, like say I've got this guy here, this is the one at the top of the angle, so I'm making it stretch the angle upwards like this. And then in order to not just have the top of the waveform go like, whoa, over in a big swing, the next one next to it is pulling it back down again. And then in order to not have the top of the wave go, whoa, down here, this one's pulling it back up again. They alternate in direction, and the more exaggerated an effect you try to get, the harder they end up pulling in these opposite directions on alternate samples. So it acts pretty weird. This is also one of the reasons that with a lot of my filters, particularly IIR filters, they're interleaved. I've got separate IIR filters for these ones that will end up trying to go the same direction if you were exaggerating the effect, and the ones that are going the opposite direction if you're exaggerating the effect. I would like those to be separate filter buffers so that they can have the distinctness and sort of hang on to that. Now, as far as extremely accurate square wave reproduction, I'm not sure if there might be a mathematical formula for what you'd need in order to make it do this. Like if we've got -1 and +1, and this is our maximum sample and this is our maximum other sample, then we might say this one might just start going, because what we're doing is we're trying to deal with the reconstruction filter in a way that's similar to a brick wall filter or a sample rate conversion, where it's making this oscillation that's literally at the sample frequency. This is literally the Nyquist frequency, so it's a illegal signal. If you went and alternated between +1, -1, +1, -1, possibly more, then by definition, either you have the highest possible sample frequency that you can represent, or you have literally nothing, because it's an illegal signal that you must not represent. Which is an interesting question, and I think people have different answers for that. I've seen converters and sample rate converters, including this one that I heard about called Brick, that I have downloaded. Since I'm a Mac user, it is available to me, and there's something else which is PC only. But people are doing things with regard to like wild sample rate converters. This is the one that I heard about. It's called Brick. It's old and runs on older machines and seems to still work on a current machine. And it seems to be doing a thing where it has very good rejection of stuff beyond the Nyquist frequency, but the way that it behaves, where its behavior as you go up to the Nyquist frequency is a sort of, it goes up to the Nyquist frequency and then sort of splats there rather than bouncing off into aliasing. And I think this is because it's including the literally 22.050K somehow. I'm not really sure why that is, or not really sure how it's doing what it does. But the other option is to have it so that it completely rejects that frequency, at which point, rather than going up and making a splat of more energy literally at Nyquist, it would go up and become silent and fade out as it started to hit Nyquist. And those are ideal behaviors, because if you don't have ideal behavior and you're going up to the Nyquist frequency, what happens is you reflect off, and then you have these other like harmonics and things that happen, and it's all this aliasing stuff, which on a frequency diagram it looks like that. It looks like stuff is bouncing off of the frequency. So your question about what is the sharpest possible square wave representation in digital land, I don't know. It depends upon how we represent these things. But it's probably something kind of like this. It's probably something like a idealized sample rate conversion where the samples end up being placed like this. You've got some of them at the maximum range, and then they start doing like bouncing all the way back to, this is negative, bounces all the way back to positive, and then negative again, and then positive again. And the end result that you get, in theory, would be a little tiny ultra sharp waveform, except for that's much smaller than the sample rate, so you might have something kind of like that, where you could do almost arbitrary sharpness, but the total volume that you're able to access is limited by how hard you're pushing all of these other samples being out of line. It is totally weird. I'm not sure. I'm just saying, like, there is going to be, because these sample things and the reconstruction filter are able to pull the sharpness out to be steeper. If you're able to exaggerate the effect by, like here, I'll draw, if you did a naive connection between the two things, it'd be as if you were trying to do a sample pattern like that. Hey, see you later, Mute Tourette's. the reconstruction filter would take a pattern that looks like it's supposed to be making a shape like this and turn it into a square wave output in which the reconstruction is calculated just right. And the vertical part is as steep as you can get it and exactly shaped in such a way. And it's all based on how far you can pull away these surrounding samples. They're never just sitting on the output waveform. They're the signposts that the waveform has to go around. And done wrongly, you can have the waveform like going beyond the power supply rails because the samples have gone too far. But arranging them correctly means that maybe you've got a sample that the signal doesn't actually go out as far as. And it's defining a shape more like that, but it's defining it in such a way that the central area is using the full range of the steepness that those two samples can represent. Oh yeah, no, digital is super strange. This is the Gibb effect stuff that Mutaretz was talking about, and that's why it becomes a problem, is that if you naively turn up samples to be louder, what happens is you're also turning up these instructions to the slew rate, and you can create overshoots and unpleasant behaviors. And there's a lot of stuff out there, like current level meters often do this, and there was an SSL meter that did this. And they do digital clips and also analog clips. And the digital clips is the sample beyond 1 to -1. And the analog clip is when we reconstruct this, does this make the output wiggle go beyond 1 and -1? And generally, if your output wiggle goes beyond the analog thing, things can be bad. And I can show you just how bad also, possibly using one of these. I'll use this corner of this. Check this out. Supposing we've got a dotted line and that represents the waveform. Then, supposing we have a particular kind of op-amp. Oh, so this is simply holding level back. You could simply hold level back until ISP are 0, or you could manipulate the samples to cause distortion and roll off high frequencies. That would work too. ISP is a factor of how much clipping you've got in there. So here is a horribleness that isn't even digital anymore. This is part of analog horribleness. There exists a op-amp where if you clip the rails, it goes through to the opposite rail. It's one of the TL07 op-amps, at least some version of it. So I think a TL07-1, perhaps a TL07-2. These are not designed to be clipping them. Some of them might have piece of my chair falls off periodically. I'm going to be gluing this on one day. So I'm not sure exactly which of these have this particularly bad behavior, but what it would do is this. That'd be the output of your op-amp. So, yeah, your tweeters are going to be real happy about this because remember, this is an op-amp in the analog world after your deconstruction. So if your intersample peaks go beyond the rail and you happen to have one of these op-amps in your audio output and it happens to not have any kinds of capacitors or whatever afterwards to smooth it off, technically you could produce this effect. You could produce the effect where your intersample peak makes a horrible spike that blows tweeters and is just horrible, nasty grunge. If it's not super loud, then it might just make horrible, nasty grunge. But that'd be a case in which the excessively loud intersample peak, rather than just making a hard-edged transistor clip on the output, which is bad too, would make a catastrophic mess on the output. So yeah, there are reasons to watch out for that kind of thing. So we are now all the way to 12:51, so there's about 10 minutes. Bernie has just seen what happens with some of these op amps. Yep, this is... I don't think all the TL07 op amps do this. I just know that there are op amps that exist to which if you clip the power supply rail, you get to the opposite side. And that is terrible, audio-wise. You do not want to deal with that audio-wise. In fact, I'm not sure I'd want to deal with that plugin-wise. I don't think I've made anything that does that, and it might be a good idea. Actually, you could probably do it with ULaw. You could probably make ULaw do it. So David will probably do this at some point. Rep speakers. So it's getting on to the last few minutes. So does anybody have any other questions? Well, I got time to handle them. I need to go off and make myself some late lunch or early dinner, or get it ready anyhow. And I'm going to be doing some more of the floating point dither recompiles. I'm doing the Windows one, so I have more than 130 of the things. And I haven't done any of them yet, except for MV, which was the first, and dither float. But it's going to take me a little while, and I'm going to try to find a preview of the hosting that I'm going to use in order to, when the new version of newupdates.zip comes out, I will be hosting it on something that's not going to get my current hosting in trouble. And we'll do that as a sort of preview before moving to the fully revised Air Windows website, which will be quite different and probably very minimalist. So your Forex has one. Dither float is two things. Dither float is just a tool to demonstrate the new dither that I implemented to the plugins, and it also demonstrates the concept that you do get truncation in floating point values. It makes the floating point value itself like a bit crusher. So it's mostly about that. That said, no, this is the current dither float. I've been updating it as I go. That said, the current dither float and the first one that came out, if you put the offset, which is like the bit crusher part of it, literally to 0, so that it's not doing the exaggerating the effect at all, what'll happen is if you're running on a 64-bit bus, that dither float specifically will apply the floating point dither as if it was working on 32-bit. At that point, if you save as 32-bit floating point out of the system that's running a 64-bit bus, you're technically dithering it to the 32-bit floating point output. So that is the one place where you can do that, because normally, and this is the case with MV, and this is the case with all the different stuff, if you're running the 64-bit VSD, if you're running the VSD that has the double replacing bus, and it's what they're calling the 64-bit bus, and none of its samples are 32-bit samples, all of its samples are already 64-bit samples, the Air Windows plugins will dither those to 64-bit. So this is excessive. If anybody says that they can hear the difference between the dithering and not using the 64-bit bus, I'll know that they're just full of it, because it is excessive. You're getting basically 50 essentially the same thing as 53-bit fixed point on even the loudest sounds, and then all the quietest sounds are even much more than that. So you do not need to dither to 64-bit, but since it is what my plugins do when confronted with the floating point thing, I do it anyway, because why not? I've made it so that it's pretty cheap to do, and it's just the principle of the thing, rather than doing anything where you'd hear it. Now, like I said, if you're using dither float is the one place where both of the things are using the 32-bit scale. And in fact, using dither float, if you're using it on 64-bit, part of it being able to show you the clipping, show you the truncation, which is not the same thing as clipping quite, with the same offset slider, means that running it on the 64-bit bus, you offset it, and it, what we call, casts the output word to a 32-bit float inside the plugin. So even if you're on a 64-bit bus, if you run dither float, it will change it to a 32-bit bus for long enough to do the truncation and then change it back to the 64-bit bus to output it. So dither float can be used with the offset all the way at 0 to act like a dither plugin for outputting 32-bit floating point. Now, the fact that that's technically something that you can do is a whole different question from, do I need to do this if I am sending a mastering engineer my 32-bit files, or will it be a problem? And the answer to that is pretty clearly, no, you don't need to do it. The reason I'm doing it is because people stack up so many plugins. And because I identified it as a thing which generates noise or distortion, and that's just what I do. So, if you were outputting any form of output file, technically you don't need to do any of this stuff. And if you're outputting a 32-bit file, you could use dither float and dither to the 32-bit, and nobody's really going to notice. The worst that'll happen is in the very loudest parts, it's the equivalent of outputting to 24-bit without dithering. And that's already, some people like Bob Olson can hear truncation on that level, but we're talking about, he might be listening to the quiet parts of the sound, because he's talking about 24-bit fixed point when he talks about that. He'll say, like, I need people to go back and dither the stuff that they give me, because sometimes they give me the stuff and it's kind of crunchy. He'll be talking about 24-bit fixed point, and he's also talking about stuff where in the 24-bit fixed point, you've got like bass notes or something where you can plainly hear any crunchiness that exists. If you have loud sounds, they'll tend to mask that stuff. So it's going to be impossible to hear the truncation directly off of any 32-bit float truncating, which is why people aren't concerned about it. So yeah, let me take a few minutes or so to just cover the last piles of questions. I just had to start talking about floating point dither at the last minute. I'll keep you covered. I'll talk about whatever is necessary. Tony, I don't think you should necessarily, it depends. Like, my plugins don't have to forget dithering, and so they don't. They do the correct dithering no matter what floating point output they get. And I came up with the accurate numbers for whatever it is, and I just do it because it's the correct thing, and I don't really care whether it's audible to the ear or not. I care about whether it's building up, and I care about whether it's the correct thing. You don't need to worry about dithering if you're outputting any kind of floating point thing. You don't need to worry about it because you're never going to actually notice the difference, neither is your mastering engineer. It's the kind of stuff that plugin designers might be worried about. It's not that you should or have to forget. It's that it's not going to matter. And it's definitely not going to matter in terms of anybody ever complaining about it. Like, once you're at the output, that's kind of, you've already done all your calculating and stuff, and nothing you do at that point onwards is going to cause that much damage. Euphorics. As far as the dither being more pleasing than the sound of an increased truncation, dither is injecting noise into the signal to make the truncation stop happening. So it's kind of like replacing the truncation, but it's also just what you do in order to have a statistical average of a signal between one point and another and have it averaging out. So there's nothing just about injecting noise into the signal. It has to be a very specific amount over a very specific space. And but that is still all you have to do. The dither is nothing but coming up with exactly the right amount of noise and putting it in exactly the right way so that anything else is no longer has any of the truncation anywhere. And you can still get truncation audibly into noise itself. Like I've talked about this with people many times, is there was that time when I thought that I could demonstrate that, you can still hear low bit and truncation even on plain noise. And I said, look, I can prove it. I'll take a double-blind test and I'll do it. And I came up with a low bit thing, which was like 3 or 4 bit or something. And I had random white noise, purely and totally random. And I effortlessly told the difference between the 3 or 4 bit noise and the high resolution noise. I could tell it every time. It was not subtle. At least it wasn't subtle to me. And I was like, haha, I showed you noise isn't just noise. There's no such thing as self-dithering. The noise floor, having a noise floor of a certain level does not in any way mean that the digital can just be truncated. Like, if you've got louder noise, you've got like minus 60 dB noise, that doesn't mean that you should just truncate. Never mind the fact that the noise might not be perfectly white noise either. And I'm like, haha, I could tell the difference every single time. And this one guy, I forget who it was, I keep thinking it was Bruni Patsis, but I'm not sure that it was like, that's very good. Now can you TPDF dither your noise and try it again? And it went, okay, sure. It sounds like along the lines of what I'm trying to argue people into doing. So I applied TPDF noise to the already noise that I had. So I added exactly white noise at a very controlled level to the already white noise that I already had. And since it's TPDF, I added white noise twice at this very small level to the larger white noise that I already had, and then truncated it. And then I tried to see whether I could tell the difference, and all of a sudden I could not. If you dither white noise, you can make it so that you cannot tell the difference between low bit and high bit, no matter what level it is at. And if you don't dither the white noise, then you can tell the difference. That's the wonder of this stuff. It's applying exactly the right level of noise statistically into the truncation process. And it's kind of neat. It's kind of like magic, because you wouldn't think that like full-scale noise, full-scale white noise, that you'd be able to tell if you truncated it or not. It seems like, well, but that's just noise, so it shouldn't change anything. And then if it changed anything, it shouldn't make any difference whether you dithered it or not, because it's still just full-scale noise. But that's what happened, is I dithered it, and then there was no telling the one from the other. It was literally exactly the same. And there was an unpleasant quality to the truncated white noise that I did not like. I was like, see, this sounds bad. And I dithered it, and the unpleasant quality of even the noise went away. So, yeah, dithering is always good. We like dithering for things. So yeah, what's next in line? If I'm not mistaken, I'll go and actually look. I've got a calendar. That'll be my final act of the stream, and then I'm going to go off and do other things. The next thing to come out is Purist Squish. And not just Purist Squish, a debugged, improved Purist Squish, where I found something that wasn't perfect about Purist Squish, something that was being updated like every sample buffer rather than every sample. And I fixed the bug, and I put out Purist Squish, or I am putting out Purist Squish next Sunday. And you'll get the ultimate, smoothest compressor, the compressor that uses the same technology as capacitor, but for a compressor rather than for filters. And that ought to be pretty cool. And it will have the newest form of floating point dither. So that is what's next in line for plugins. And having said that, yeah, dither only when reducing bit depth. And many things are reducing bit depth, but in the stuff that we're talking about, you don't really need to be worried about that kind of stuff. This is the kind of thing that maybe algorithm developers, such as myself, might be worried about. As a end user, like if you're going to CD quality or if you're going to 24-bit, maybe if you're going from a 64-bit floating point bus to a 32-bit floating point bus, but be aware that if you're worrying about that, you're over worrying about it. And it's still correct to dither it, but only because technically that's what one would do, not because you're ever going to be able to tell. Or the mastering engineer or anything they do will ever be able to tell. Like, Bob O is so good, and he has such good monitoring equipment and stuff that he can hear if it's 24-bit fixed point going wrong. But I do not think that even Bob would be able to tell if the 32-bit float stuff was dithered or not. And he's very sensitive to that stuff, as am I. So we care about these things. But, never actually worry about the 32-bit dither, and do it if you want to. It's kind of the same thing, like if it mattered to you to like say a little prayer over the final mix before you sent it out. And if that matters to you, or if it matters to you that you like touch your nose before sending it out and that gives you good luck, or that I'm trying to think of other things. Like if you need to, actually turning your lights down to do the mix might be effective because you'd be heightening your audio sense. So if you finished up the mix and you mixed it on when it was dark in the room, and then if you were ready to export it and you had your lights on and went, oh wait, I need to turn my lights off before I export this so that it's like the way it was when I mixed it, that's about as important as dithering to 32-bit before sending it to your mastering engineer. It's that little of a effect, and it's much more about like, is this making you happy? And is this something that you care about to the point that you'll feel that you did all that you could? Because whether the guy in the end of the chain that gets it is going to be able to tell what you did, it's going to be about the same level as whether you turned the light on or off before exporting. Is that going to make you feel good or not? So, and then if you have 27 plugins stacked up in an internal bus and then you're bouncing it to things and then remixing those, then maybe it might even end up being, I don't know. This is just the thing that I do. So what I'll do also is I'm going to go off and make another cup of coffee and do other things today. I'll be doing some of my compiles for the Dither Float, and we will see progress in that eventually. And I will talk to you guys later because I am never done either, as David so aptly says. So I'll talk to you later.